2.2 is titled, I can find it, the limit of a function. So there are lots of ways to present or acquire calculus. The order in which you do things is really optional. As I talked about a little bit yesterday, there are three primary topics within calculus. There are limits, there are derivatives, which I'll abbreviate derivatives, but I'm just going to make a short list here, and then integrals. And you can start with any one of the three. The order in which you start the topics doesn't matter. In fact, when I took calculus in high school, we started with, I think we started with limits, then we went to derivatives, and then we did integrals. So like the order that we're going to do it in this class, basically. But that's not historically how this was developed. In fact, integrals historically came first, which is kind of weird, the way that Newton developed them. And I guess Leibniz probably developed them the same way. I don't know for sure. But the way Newton developed them, integrals came first. So when I took calculus in college, I took essentially Cal 1 at well, it wasn't a university, but at a college, we did the historical route. We did integrals first, which feels kind of weird if you take a class in high school and then you think of math as being sequential usually, right? You have to study arithmetic before you can do algebra. You have to study algebra before you can do trigonometry or whatever order you go in, right? It seems sequential, and it generally is. But in this case, the sequence doesn't matter. And then we did limits, and then we did the derivatives. We did derivatives last, which is kind of weird. But what you can do, and I've taught it this way before, you can start with derivatives, and then do limits, and then do integrals. You can't do limits last. The reason for that is limits. Oops. Oh, sorry. Struggling with the interface here. Limits are utilized to do derivatives and integrals. So the limits feeds into both of these. So you can start with limits, get it out of the way, and then talk about derivatives and integrals. Or if you want, you can start with derivatives, get partway through, kind of get stuck. You don't have the tools to finish the problem, but you need limits to regain traction on what you're doing. Or you can start with integrals and start doing the problem, doing what integrals are. And you kind of get stuck. It's like, well, I'm not able to leverage merely algebra and geometry in order to get the result that I want. I get stuck. You need a limit in order to get the result. So to me, it's interesting that this is a set of topics where the order in which you begin doesn't matter. But if you don't begin, I guess the in quotes correct way, you kind of get stuck and you're forced to go do limits. You can't finish either derivatives or integrals without doing limits. Anyway, there's just an overview of how the concepts are related. And of course, we haven't talked about any of these at all, really. So maybe that is kind of vague or abstract because you don't already know what I'm talking about. And of course, we're going to clarify all that. So we're going to start with limits, and we're going to treat it like this. Rather than treating it like a topic to be learned because we need that topic, I'm going to treat it like a tool to use later for other topics. So we're going to talk about limits. We're going to spend today and tomorrow, and then probably Monday as well. Probably 3 days, I think, will be sufficient. There are 4 sections in the textbook we're going to cover: 2.2, 2.3, 2.4, 2.5. 2.5, as I mentioned yesterday, we're not going to spend a whole lot of time on it. I'll talk about it. I don't plan on testing you on it. It's something that it's full of technicalities. It's kind of tedious. To me, it's really interesting. I like it, but that's why I got a math degree, because I like it. Not all of you are math majors, so these really nuts and bolts technical details aren't essential for everyone. If, as I mentioned something similar yesterday, if all of you were math majors, the class would be different because I would be presenting material differently. I haven't checked, but I imagine most of you are not. Anyway, when I start talking about the limit of a function, there's a couple of ways to just start this topic. And in the classroom where, I can see you, you can see me, and if I ask a question, I can see if you're furrowing your brow, or if you're just waiting for me to tell you the answer. Sometimes when someone asks a question in a classroom, you're not sure, is this rhetorical? Does he want an answer, or is he just setting up what he's going to say next? So I'm totally okay with any one of you just jumping in and answering a question that I propose. I am going to be doing them rhetorically because we're not in person in the classroom, so it's a little uh what's the word that I want? I don't know. It's just it doesn't work as well in an in-person classroom, I think, to have a discussion, right? Um I've had Zoom meetings, and you've probably in your other classes had discussions via Zoom, but I don't have a camera. Uh, I don't have a webcam that works, and some of you it looks like don't either. So yeah. Anyway, bit of a side note. It's just easier in person, right? So I'm going to be posing some questions, and totally feel free to unmute yourself and answer. Absolutely. But I am going to be treating them rhetorically, as in I'm going to answer them as well. So, one way to start this is to talk about what does it mean to be near something? What does it mean to say that, say, X is near to? What does that mean, right? Like if I were to say, I don't know, Japan is near South Korea. Like if you understand what the globe looks like, yeah, Japan's pretty close to South Korea, or best Korea if you like. Um, on the scale of the globe, yeah, those are pretty close. But if I were to say that Tokyo is near Pyongyang, you might say, well, on the scale of a city, not really. They're what, hundreds of miles, over 1,000 miles apart. They are not that close together on the scale of a city. On the scale of a country, yeah, Japan is pretty close to North Korea. They're relatively close, right? Japan is not close to North Dakota, but it's close to North Korea. But on the scale of cities, Tokyo is not that close to Pyongyang. It's just not that close, right? So when you talk about being close to something, the scale matters, right? Now, when we're talking about just numbers on a number line, like if I make a number line and I mark down 2, I can ask, okay, what would be a number that we would consider close to 2? Um, and I've only marked down 2. I haven't marked down anything else. Can someone in the Zoom call just suggest what number would be considered close to 2?
One.
Yeah, 1. Thank you. Now, where should I mark 1? Is 1 marked over here, or somewhere in the middle, or right next to it? That's a choice I have to make. What should we go with? Where should I put 1?
Behind 2.
I'm sorry?
Behind 2.
Behind 2? Okay. Like right behind. Okay. So if I put 1 like right here, right? I've chosen a scale. Now I can say here's 0, here's -1, here's 3, here's 4, right? I've chosen a scale because I've decided where another number is. So if I were to say something like, I guess, what would that be like? Say 3, 4, 5, 6, 7, 8. On this scale, since I've chosen 1 already, 8 is not close to 2, right? It's just, it's far. It's not near, it's far. So near versus far depends on what scale are we talking about, right? Um, so which is closer to 2, 1 or 3?
1.
1 is closer than 3?
They're the same.
Yeah, exactly. Yeah, they're the same. So you have a behind, you have an in front of, right? You have numbers on the left, numbers on the right. But for every number to the left of 2, it has sort of a counterpart that's equidistant, but on the other side, right? 1 and 3 are the same distance from 2. And in fact, each one of those is 1 unit away. So one thing to think about is when you ask how far is 1 from 2, oh, well, it's 1 unit, right? 1 unit away. How far is 3 from 2? Oh, it's 1 unit away. right? One thing I'll note is that if you let's do it this way. If you subtract 2 minus 1, you get 1. If you subtract 3 minus 2, you also get 1, right? You subtract the smaller number from the larger number, you get the distance between them. What we're going to want to think about sometimes, not all the time, but sometimes, is if you don't know which number is larger, like if I were to say, here's x over here, right? And I ask, how far is x from 2? Now, the way I've drawn it, I know that 2 is greater because I put x on the left. But if I don't mark x anywhere, I just say, well, x is some number. And I ask, how far is x from 2? Right? Well, I could say, oh, well, that's going to be a 2 minus x, right? But if x is over here somewhere, oops, let's put it there. If x is over here somewhere, well, x is bigger. Then 2 minus x is now a negative result. So what I have to do is use the absolute value so that the result is always positive. This is how far x is from 2. And if I want to change the order and do absolute value of x minus 2, that's the same thing, right? Because if you take two numbers and subtract them and then find the absolute value of the result, throw away the possible negative value, then the order in which you subtract it doesn't matter because you're throwing away the minus sign afterward anyway, right? So if you want to know the distance between two values, it's always the absolute value of their difference, and the order of the difference doesn't matter. Okay. So if I were to redraw this number line, let's say like this, put 2 in the middle, and I were to put 1 here, on this scale, I guess, okay, is 1 close to 2? Is 1 near 2? And I might say, well, maybe, but there's all this space here between them. There's lots of numbers between 1 and 2, so they're closer to 2 than 1 is. So I could say, for example, 1.5. Right? That's closer to 2 than 1 is, right? It's closer or nearer. Nearer, right? We're using a comparative now. To say that something is near to or close to 2, if I just say, what does it mean to say that x is near 2? Like, well, it depends. When I say nearer, it's a comparative. Nearer than 1 is. 1.5 is nearer to 2 than 1 is. I'm making a comparison. I already have a scale set up because I'm comparing to 1. So if I want something even closer, well, like 1.9, right? That would be even closer, right? 1.9 is pretty close to 2. And if I want like 1.99, that's very close, right? And if I want to redraw this and do a different scale, come on, using the auto draw tools here, and I want to put 1.99 right here, I've really zoomed in my scale, right? I took this entire thing here and I stretched it out to be much larger in scale. And I can say, oh, well, here is 1.995, halfway between 1.99 and 2. And then like say here's 1.999. And if I want to zoom way in, I'd say, okay, well here, change colors here. Here is 1.9999. Right? I can get down to 4 decimal places because of the scale that I chose to use. I'm choosing to use really fine-grained numbers.